Hello everyone. Let us now discuss how can we solve this problem. Find minimum time to reach last room 1. So this is the first question, and if you have solved with Dijkstra's algorithm, I'll explain you how this Dijkstra's algorithm work. So first thing, let us go with the question. We are given with n by m, something like this. It is nothing but a grid, like a matrix. Okay. Now you are given with a 2D array move time of size n by m. So the same grid is considered as move time, where move time ij represents the minimum time in seconds when you can start moving to that room. So clearly mention that minimum time in seconds when you can start moving to that room. Like if you have 0, if you have a 2, if you have a 4, then at 0, that means initially you are starting at 0. You start from the room 0 comma 0. Let take this example 0 comma 0. This cell you are starting with 0 comma 0 at time t is equal to 0. So here I have time t is equal to 0 and can move to an adjacent room. Moving between adjacent rooms take exactly 1 second. So I want to move to this room, right? This room too. But clearly mentioned that I have 0 as the time. So to move to the next cell or room, minimum time in seconds represents the minimum time in seconds when you can start moving. When you can start moving, that means this will change to 2. It is nothing but you are waiting till 2 seconds and you got 2 seconds, then you move to the 2, and let me store this something like I have moved from 0 to this cell from waiting with 2 seconds, then it will become 3. So at this point, I have the time have become 3. Why? Why? Because to move from one cell to an adjacent cell will take exactly 1 second. I think it's clear for you. Uh, right? Okay. I have 3 now. Now the goal is return the minimum time to reach room n minus 1 m minus 1. That means the last room, the corner room, the nothing but the bottom right room. Two rooms are adjacent if they share a common wall either horizontally or vertically. It's nothing but if you have solved any grid problems, it is nothing but you can move top, right, bottom, left. That's it. Okay. 2 is less than or equal to, these are the constants, and they are also even less, right? They are just 50. Now let us go to the examples. Here I am starting at 0. Here I am starting at 0. Now I can move to the right or I can move to the bottom. So if I move to the right, like if I move to the right, then it would take 5. I have explained you why I will get 5. Why? Because I wait till 4 and then go to the cell and increment the seconds, increment the time by 1. Okay. Now, if I move 4, it's the same thing. Now I have 5 here. Now, here I have 4, right? So, to move to this 4, minimum time I need is 4, right? But if you see, I already have 5. So, why I have to wait? There is no need to wait, right? So, when you have a cell which is lesser than the time, then go to that cell by incrementing the current time. So I'll tell you something like a code, a statement. It will make clear that how you can move to the adjacent cell by taking the time. Now 5. Then I am moving to this cell. Okay, I am moving to this cell. But here this cell, this cell is having less time, and I have the current time as 5. So the time will be already 5. So I am moving to the adjacent cell, so it will become 6. Now I have reached n minus 1, the bottom right cell n minus 1 and m minus 1. So I'll stop here and return 6. But what if there is, but For example, I am telling you that an example. What if there is a 2 here? So there will be conflict there, right? So I have to move to this 2, right? I have to move to this 2 and then move to this 4. I'm just assuming like that. So if I move to this 2, then it will be 0 here and it will be 3 here and it will be 4, right? I just have 3. Then I need to wait till 4. I need to wait till 4, and when my time becomes 4, I just increment my time by 1 and go to 5. So it's not a single path. I can't go and tell that a single path. So what I'll do is go to the next example, right? Here I'll go here, I'll go here, and I'll go here. So I just need 0, right? So I have 0, and here to move to the next cell I have incremented it by 1. To move to the next cell I have incremented it by 1. You might consider, bro, you didn't take the time, you didn't take the 0, considering 0. When I have, I'll write it here. When I have much time than the required time, then then only increment by 1. Only increment the time by 1. I think it's clear for you now. So if I had a much time, as here I have 1, here I have 2, so at the time I can go, right? Now here I have 0, then I can go here with the time of 3. I think it's clear for you. Now here I have 1 1 0 1 1 2. Now I can go here, then the distance or the time will become 1 plus 1 2. Clearly think that 1 plus 1. I am telling that 1 plus 1. Now, here I'll go to 2. Here I'll go to 2. I already had a 2. 2 plus 1 will become 3. I think it's clear for you. I just gone to this path. But if I write that, if I write something like, so the time will be maximum of, currently I'll take that as time. So wait, wait will be time, comma, maximum of time, comma, here I have 2. So maximum of current time, I got current time as 0, but here I have 4. So maximum of current time, comma, next the time to the adjacent, right? Time, comma, minimum, the grid, something like grid of x, y plus 1. I think I'll use something like another variables in the code, but it's the same thing. Wait time to get to that, to reach to that matrix or cell to the next adjacent cell, then wait is equal to max of time, the current time, comma, grid of x, comma, y. If, imagine if I have 0 here, if I have 2 here, then 2 plus 1 will become 3. Now, if I have a 0 and also a 0, the max is just 0 and I am incrementing it by 1. And if I have the current time as 1 and the grid is lesser than 1 plus 1 will become 2. I think for now it's clear. Now let's go to the intuition. Is I If you see, I am storing this somewhere. I have to store this somewhere. I have to store this somewhere, right? So for that I'll create a matrix again and name it as uh, I'll name it as distance, right? Okay, it's perfect. So this is the given grid or minimum time, the whatever the name might be. So this is the distance matrix that I created. Okay, at 0 the time is 0. So what will this distance store? The distance will store the time to reach to this cell, the time to reach to this cell, the time to reach to this cell. I think it's clear for you. So distance will store, wait a second, sorry, don't know what it happened. Yeah, distance cell will store the time to reach that cell. Okay, okay. Now I think it's clear. Okay. Now I can go, I can go to the right, I can go to the bottom, I can't go to the left, I can't go to the top. So if I went to 2, now what I need every time, what what I am expecting. So if I got a 2, right? If I got a 2, what will be the time? Max wait time will be max of time comma grid of x comma y plus 1. 2 plus 1 is 3. Max of 0 comma 2 is 2. 2 plus 1 is 3. And the cell is okay. And the cell is at 0 comma 1. Now I give the indices 0, 0, 1, 2 and 3. Here also 1, 2 and 3. Okay. 3, 0, 1. Now here I have 3, right? 3 plus 1 is 4 and the indices are 1 and 0. But wait, my friend, here I have 3 as the time to reach here. I have 4 as the time to reach here. Now, what will I choose every time? I'm not so dumb that wait a second, right? I will choose I will choose 4. So if I choose a 4, then I'll go to the maximum time, but I need the minimum time to reach, right? So I have to make a data structure so that the minimum time will be at the top, and that data structure is a priority queue, right? The minimum time will be at the top. Okay, I went here and the time I got is 3. Okay, I'll write it here. Okay, I went to here and the time I got is 4. But then I will traverse or visit this cell 0 comma 1. I'll take that and I am just popping it out. Pop out. Now I have this 3. Now at this moment of time where I can go. Now at this time I have 0. Okay, I have 0 and I have the current time as 3. Now, what I'll do is push back max of 0 comma 3 is 4. Okay, 4. And I'm going to this cell and the time is 3. Okay, the time is 3 and this here I am checking here grid of 0 comma 0, right? When I check the left one, I got max of 0 comma 3 is 3 plus 1 is 4 and 0 comma 0. But this will not going to this path again. I'll tell you why and how. Now I can go to the bottom. I'll tell you why it doesn't go to this cell. I'll tell you how. Now I go to this cell and it is having 5. Max of 5 and 3 is 5 plus 1 is 6. Now I go and I'll store this tuple 6 comma where I got it 1 comma 1. Okay. Why I am storing like this is because minimum will be at the top. Okay. Now go to the right. I have 1. The maximum from 3 and 1 is 3 plus 1 is 4. So it will store 4 here. 4. 4 and let me just do this here and I am writing 4 comma 4 comma 0 comma 2. Okay. Now all those things are over. That means that all the directions I have met through. Now I'll go through the second thing here 4 comma 0 comma 0, right? I am at here. 4 is the time time is 4. Time is 4. Now the distance is 0. So when the time is greater than the distance of 0, that means x comma y. Distance of x comma y. X comma y are x is this and y is this. So what does this mean? Time is greater than distance of x comma y. That means I am going in reverse. I am visiting the same cell again. So skip this. Continue. That means I am not going to visit this cell. Why? Why? Because distance of x comma y is lesser. So to visit this cell is taking only 0 as the time. But you are telling me that 4 is the time. 4 is the required time to reach 0 comma 0, but the distance, the given matrix or grid is telling me that 0 is the only thing. Why you need to take 4 as the time, 4 seconds as the time. So I am visiting this, and again nothing to do with that 4. Okay, now I have 4 0 comma 4 comma 0 comma 2. I think I didn't forget anything. Okay, 4 comma 0 comma 2. 0 comma 2 is here now, and there is no need to check again and again that time is greater or not. I'll go to the bottom element, and I have 2, and the maximum from 2 and 4 is 4 plus 1 is 5. I go to the right, I have 4, maximum from 4 and 4 is 4 plus 1 is 5. Okay, I think for now it's okay, it's clear now. But sorry, I haven't pushed this 5 here in the periodic queue. So okay, 4 here, and then I'll remove these things, and I'll remove these things just for for the space constants. Okay, I have 4 1 comma 0. 5 is at 1 comma 2, and again 5 is at 0 comma 3. 5 is at 1 comma 2. 5 is at 1 comma 2. 5 is at 0 comma 3. 5 is at 0 comma 3. Okay, now let me go to first thing, 4 0 comma 2. 0 comma 2, I think sorry, this is already visited, so I am removing that 4 0 comma 2. Now I have 4 1 comma 0. 1 comma 0 is here. Now no need to go to the same cell again and again and again. Now the time is 4, which is greater than the distance of x comma y, grid of x comma y. No need to go here. Time is greater than grid of x comma y. No need to go there. Now only option 3 and 6. Grade maximum is 6 plus 1 7. Now push that into our periodic queue, right? Now imagine, like, I am missing out on something is 7. Okay, I'll tell you 2 comma 1, 2 comma 1, right? 2 comma 1. Now 4 1 0 is that I am missing, right? I am not removing that every time. Now 7. Okay, okay, now I have 5 1 comma 2. 5 1 comma 2 is here. No need to go here again. Nothing to do there. Now I can go to the bottom. First I'll go to the bottom. I have 7. Maximum of 5 comma 7 is 7 plus 1 is 8. Now go to the right. Maximum of 5 comma 6 is 6 plus 1 is 7. Now push these two into our periodic queue. But before that, let me remove 5 1 comma 2. Now if I push that again here, I have 8 at 2 comma 2. I have 8 at 2 comma 2. First 7 is at 1 comma 3. 7 is at 1 comma 3, and 8 is at 2 comma 2. Okay, 8 is at 2 comma 2. Now next thing is 5. 5 is at 0 comma 3. 5 is at 0 comma 3. Okay, uh, here no need to check again. Time is greater than distance of x comma y. I'll tell you like this. Time is greater than distance of x comma y. X comma y. Uh, X comma y. If I push that periodic queue again also, I'll get 0 comma 2. X comma time is 4, and distance of or grid of x comma y is lesser and time is greater, so I'll skip it. Now here I have 7 and it is also greater, so no need. So let me remove that first thing at the top element. Now go to the next 6 1 comma 1. 6 1 comma 1, same thing again. No need to check whether is it greater. It is already greater. Time, is it greater? Okay, greater. It is greater. Okay, greater. Now remove this 6 1 comma 1. Okay, 7 2 comma 1. 7 2 comma 1, here it is. Now go to 4. Go to 4. Now I am not gonna check this yet. You know the reason. Now 7. 7 plus 4 and 7, the greater is 7. 7 plus 1 is 8. Here 6. The greater of 6 and 7 is 7 plus 1 is 8. Just remove this 7 2 comma 1 and push this 8. This to 8. 8 2 comma 0. 8 2 comma 0. 8 2 comma 0 and 8 3 comma 1, 8 3 comma 1. Now I have 7 1 comma 3 here. I have 7 1 comma 3. Okay, I have 7 1 comma 3. If I take that 7 1 comma 3, go to this, no need. Go to this, no need. Why? Because I you know the reason. Here also no, you know the reason. Okay, go to the bottom. Here I have 8. Maximum from 7 and 8 is 8. 8 plus 1 is 9. Just push this. But before that, let me remove the top element, right? And then push that 9, right? 9 will be at the end. 9 is at 2 comma 3. Okay, now I have 8 2 comma 2, 8 2 comma 2, where it is? Yes, here. Now is there anything to go here? 7, okay, greater. 5 is greater. Now 9 is greater again, only this cell. Now if I go to that cell 8, here the bottom is 8. The maximum of 8 comma 8 is 8 plus 1 is 9. Push that, but before that 8 2 comma 2 will be removed. So 8, I'll tell you, 9, right? 9 is at 3 comma 2. So indices 3 comma 2. Now I have 8 2 comma 0. 8 2 comma 0. Where it is? 8 2 comma 0. Here it is. Now no need to go here. Why? Because it's already greater. Here no need. Here I can go. 5. 5 is not great. 5 and 8. The greater is 8 plus 1 is 9. Is at 3 comma 0. But before that, let me remove the topest element. 9 comma 9 comma wait, 9 comma 3 comma 0, 9 comma 3 comma 0. Now okay, 8 3 comma 1, topest element is picked every time, as you know, in the Dijkstra's algorithm. 8 3 comma 1 is here. So I think, for God's sake, for God's sake, 7 and it is greater, 9 it is greater, 9 it is greater, and it you know that out of bounds. Now let me remove this. Now I have 9 2 comma 3. 9 is at 2 comma 3 here. So no need to go here, no need to go here, but I can go here. Now I think it might be something like the shortest path, right? Okay, I'll tell you the shortest path. Now here I have 9. The maximum of 9 and 9 is just 9. So I have 10. When I reach this, I'll return distance of n minus 1, m minus 1. So what will be the algorithm? First thing, distance of n by m size, m size. Okay, distance of n by m size. Now I have something like dx or something like wait a second. It is directions, right? 0 0 comma 1, 1 comma 0, and 0 comma minus 1, and then minus 1 comma 0. What does this mean? 0 comma 1, I am at this point. 0 comma 1, add 0 comma 1. If I add 0 comma 1, then I'll go to the right. If I add 1 comma 0, then I'll go to the bottom. If I add 0 comma minus 1, then I go to the left. If I add minus 1 comma 0, then I go to the top. I think it's clear for you. Now I have these things, and in that directions, after directions, I'll pq it is nothing but priority queue. Okay, priority queue. Here I'll store a tuple where I store int. Here the first int is for the time, second is for indices I and j. Okay, priority queue. Now after priority queue, while pq dot empty, but pq is already empty, so I need to push that something into it. Pq dot push, what I have to push? 0 comma 0 comma 0. Why? Because 0 is the starting time. Okay, pq dot push, and time auto, I'll write it, auto time comma x comma y is equal to pq dot top, and remove that top element, pq dot pop. Okay, now what I need to do after this? If time is greater than distance of x and y, or you can write it as, okay, distance of x comma y will be running continue, and I'll go for auto directions and I'll add every direction into it. So nx is equal to, first thing, x plus dirs of 0, and y is equal to y plus dirs of 1, directions of 1. So if nx, if it is out of bounds, I'll write it bounds out of bounds, then continue. That means I am just skipping. Now if it is out of bounds, I am continuing. But if it is not, then wait time will be maximum of time comma maximum of time comma, and what is the next time? It will be of distance of x and y. Okay, here I think it is minimum time or something like grid. I have changed the variable, but distance of x comma y plus 1, and in the pq I'll push pq dot push wait wait, and what is the new x and new y. I think for now it's clear. And if at this moment, if x is equal to n minus 1 and y is equal to n minus 1, return time. That's it. So this is the code, and you will get the code in the code link in the description. And if you like this video, do share it to friends and do subscribe to my channel. Thank you.